Hello. In this video, I'd like to run through a few of the problems from homework number 9, the application set in Math Excel. The reason why I want to do that is because you may have noticed that some of the help tools, the question help options that are presented, lead you to believe that you must use a different equation than what I've been showing in my videos. And I want to affirm or confirm that it actually doesn't matter which original formula you use, whether you use the format that Math Excel suggests, which is this format here, or if you use my format, which is this one here. Both techniques work and will lead you to the same and correct final answers, and both techniques will be accepted as far as showing your work goes when we complete our test in a couple weeks. So let's take a look at this first problem here. This is question number 1 out of 15 on homework 9, the applications set. We have a population of mosquitoes, and they obey, or the growth of this population obeys the law of uninhibited growth. There are 1,000 mosquitoes initially, and there are 1,600 after one day. I don't know if you all can read that, so I'll zoom in here. What is the size of the colony after 3 days, and how long is it until there are 90,000 mosquitoes? So first off, let me just jump in here. If you're completely lost, you may jump into the question help and either ask to help me solve this or view an example. I think most students choose to view an example because when they view that, they can complete the example off to the side and use that as a template to complete their problem on their particular set, which is fine. I think you can learn from that too. But I'm just going to press the continue button here, and I'm just going to point out here that Math Excel is going to walk you through this problem utilizing this particular layout of the question. And so I'm not going to do that. I am not going to use that layout for my example. I'm actually going to use the equation that I suggested. So I'm going to gather some of the important information and then start working on that separate sheet of paper. Okay, so here's what I've gathered from the word problem. We were told that our initial value, or the amount that we started with, was 1,000 mosquitoes, and I defined this in a prior video that this value, C, is what we call our initial value. And incidentally, the initial value in the format that Math Excel presents is this A subscript 0, A sub 0. That's also the initial value. We're told that after one day there are 1,600 mosquitoes, so the result of this function when evaluated at 1 will result in 1,600 mosquitoes. We would like to know how many mosquitoes there will be after 3 days, and we would also like to know how many days it's going to take in order for there to be 90,000 mosquitoes in the colony. Now, in order to answer these two questions, f of 3 and then f of question mark equals 90,000, in order to answer those, we need a growth factor. Now, here's where my approach and Math Excel's approach differ slightly. The growth factor that I've been referencing in my videos is simply this A value, and this growth factor is a number relative to 1. If it's smaller than 1, then we have a decay or a reduction in numbers. If it's bigger than 1, then we have an increase or growth in numbers. If I compare this A value to a portion of the expression that Math Excel likes to use, well, you need to include both E, the number E, and K, the growth rate K. And the growth rate would be E to the K power. Now, the growth rate or factor when describing this is usually referenced by the letter K, and that's a number relative to 0. If K is bigger than 0, then we've got a growth. If K is smaller than 0, then we've got a decay. And that's all well and good. That's a technique that works. That's not the technique that I've been stressing in my videos because I think this second equation is a little bit easier to work with. So now back to the task at hand. Let's use what's given in these first two lines. Let's see if we can obtain our growth factor A. Well, again, I would start off with our format, f of x equals c times a to the x power. we know that f of 1 would be our c value, 1,000, times a to the first power. But we also know that f of 1 is 1,600 mosquitoes. So if 1,600 mosquitoes is equal to 1,000 mosquitoes times a to the first power, well then isolating a is going to be pretty easy. We simply divide both sides by 1,000. We've got 1,600 divided by 1,000, which would be, say, 16 divided by 10, which reduced even further would be 8/5. And if we wanted to use a calculator to obtain the decimal, we would have 1.6. And any one of those would be perfectly fine for an a value. So now that we know what a is, and now that we know what c is, the only value that we're going to reference from here on out is going to be our x value. That's our independent variable. And so we can actually answer part A. What is the population of the mosquitoes after the third day? Well, we started with 1,000 initially. We've got a growth factor of 1.6. And again, any one of these fractions could have been used, or the decimal 1.6. Actually, let me back this up. Let me just use 1,600 over 1,000 here, because I don't want you to be tempted to use the decimal in all cases. Sometimes the decimal value is a non-terminating decimal, and if that's the case, I don't want you to round that decimal and use it in your calculations. So I think for the remaining examples that I show in this video, I'm just going to use this very first fraction and not even worry about reducing it. But we have our c value and our a value, and the power, x, in this case, is 3. Now the instructions on Math Excel are pretty clear. We want to know how many mosquitoes there are after 3 days, and the instructions go on to say do not round until the final answer, and then round to the nearest whole number. So regardless of what the calculator gives us, we want a whole number answer, but we don't want to round prior to that. And that warning, do not round until the final answer, is a reminder that this 1.6, while it was okay here because that was a terminating decimal that didn't need to be rounded, if your a value computes to be a decimal that extends beyond, say, a single decimal point, if you ever have to round that decimal, then that's going to throw off your final result, and we want to avoid that. So anyway, I've turned on my calculator. I press the on button until we get to the home screen. Now I'm going to choose option number 1 to create a new document, and I'm going to add a calculator page to work with. So we need to evaluate 1,000 times 1,600 over 1,000. And remember, I can create these fractions by pressing Control and then divide. And we'll raise this result to 3, the power of 3. The result ends up being 4,096 mosquitoes, and there are no decimals to worry about, so we got lucky there. F of 3 is 4,096 mosquitoes. Let's check our answer on Math Excel. 4,096. Losing my keyboard here. There we go. So I'll press enter, and Math Excel likes that as a solution. So again, that was solved by using our generic form from the videos this week. It did not include the method that was presented in the Help Me Solve This from Math Excel. How long is it until 90,000 mosquitoes are in the colony? Well, we're going to round our answer to the nearest tenth, so how many tenths of a day, and we're not going to round until the final answer, so we're going to be as precise as possible until the very end. So we know that 90,000 is the end result. We started with 1,000 in the colony. We're growing at a rate of 1,600 over 1,000, and we're trying to solve for x. So what I would do first is divide both sides by 1,000, and we're left with 90,000 divided by 1,000 equals 1,600 over 1,000, raised to the power of x. Now, since x, the unknown value, is sitting here in an exponent, in order to undo that exponent, we must rely on our logarithms, and we're going to use the definition of a logarithm to rewrite this exponential. The logarithm has the same base as the exponential, so I'll use 1600 over 1000. And instead of raising this base to the power of x, we're going to evaluate this logarithm with this base at the number that's on the opposite side of the equation, 90,000 over 1,000. Now, keep in mind that I'm being very deliberate here, and I'm not doing any math whatsoever. Number one, because it's unnecessary. We'll let the calculator do the work. And number two, I don't want to run the risk of rounding before the final answer. I know that 90,000 over 1,000 can be reduced, and I know that 1,600 divided by 1,000 can also be reduced. But it doesn't bother me, and it doesn't make a big difference to us right now. Let me rephrase that. It does make a big difference because we don't want to round before our very final answer. This expression, as written here, is an exact result. It's a precise answer. And as soon as I turn that into a decimal and round that decimal, then I lose a bit of accuracy, and we want to avoid that as much as possible. So let's jump to the calculator, and we'll evaluate this logarithm. So I'll press Control and then this key, the 10 to the x power. That's what pulls up our logarithm command. The base of our logarithm is 1600 over 1,000. I created that fraction bar by pressing Control then Divide. And in the argument we want 90,000, Control Divide, 1,000. And if I press Enter, sometimes these calculators are going to produce another simplified, precise final answer. That's okay, but that's not really what we're after for Math Excel. So I'm just going to highlight the last expression. I pressed the up arrow until it was highlighted. When I tap the Enter key, it copies it down. And now I'm going to press Control Enter. And we've reevaluated the expression, and this time we've got an approximate answer result, which has been rounded to the 10th or 12th decimal place right now, but our instructions said we can round to the first decimal place. And this is the first time that we've actually rounded in the whole problem. Everything prior to this was precise. So I'm going to say 9.6 days is the result. So x is equal to 9.6 after we rounded. 9.6 days. Our x value represented days. Our function result represented mosquitoes. So let's see what Math Excel thinks. So we'll type in 9.6. Try that again. 9.6 and tap Enter. And Math Excel accepted that as well. So again, that just goes to show that it doesn't matter which formula you use, you can and will still be able to complete and obtain the same and final answer. In the next video, I'll find another problem from this homework set and show you how it would look when you complete it in both ways. I'll walk through both solution sets. I'll stop this now so that this video doesn't get too long. Thanks for watching.